Okay, let's take a look at this problem where we're asked to identify cost behavior patterns. Now, I know you can see the graphs, but the writing's probably too small to read. So I've reproduced the text here, up here, so that you can read it. And it says that a number of graphs displaying cost behavior patterns are shown below. The vertical axis on each graph represents total cost. The horizontal axis represents the level of activity. Okay, then if I slide down, there's a number of activities that's pretty hard to read, so I better read that for you. And then we're going to match the appropriate item to the graph. So, for each of the following situations, we're to identify the graph that illustrates the cost behavior pattern involved. And any graph can be used more than once. Okay, so reading A, and I know that's hard to read, but just to the left of my mouse. A says salaries of maintenance workers, where one maintenance worker is needed for every 1,200 hours of machine hours or less. So what that means is 0 to 1,200 hours requires one maintenance worker, 1,201 to 2,400 requires two, and so on. Okay, well, hopefully you can see that the graph that relates to is number 10. So what might make more sense is if I do this. Is if we rename these, and then we can identify which one goes where. So number 10 really goes with A. Okay, so we have, if you will, a stepped function where costs are fixed within a very tight range, and then we move up to a next level. So cost behavior behaves as in a stepped fixed function. Some call that a stepped variable function as well. All right, let's read number 2 now. I'll slide on down to the left of the mouse, or item B, I mean. Rent on a factory building donated by the city where the agreement calls for a fixed fee payment unless 120,000 labor hours or more are worked, in which case no rent needs to be paid. So, if we slide back up and try to identify which one is item B, we have the case where fixed costs remain the same unless we exceed a certain amount, in which case the rent goes to 0. Okay, so the number 4 is really B. Okay, let's read number C now. Again, hard to read, so I'll read it to you. Electricity bill, a flat fixed charge plus a variable cost after a certain number of kilowatt hours are used. All right, well, if we slide back up here and we take a look at this one, we've got a flat fixed charge, and then after some certain level, we get a variable component that gets added to it. So number 6 represents C. So we'll jot that down. Whoop, I got it in the wrong place there. All right, let's go read D now. D says, depreciation of equipment, where the amount is computed by the straight line method. When the depreciation rate was established, it was anticipated that the obsolescence factor would be greater than the wear and tear factor. Okay, so we've got straight line depreciation. This is for item E, right? And, excuse me, this is item D, my mistake. We've got straight line depreciation, so we're expecting a straight line to be incurred regardless of the level of activity at all. And that clearly depreciation behaves as a fixed cost over the relevant range in graph 1. So 1 is D. So let's jot that down. Now we'll read E. E says use of a machine under a lease where a minimum charge of $5,000 is paid for up to 1,000 hours of machine time. After 1,000 hours, additional charge of $3 per hour is paid up to a maximum charge of $7,000 per hour. Okay, so now we're talking about E, and the charge that occurs there is a fixed cost up to a certain portion, then a variable portion, right? $3 per hour until we reach a maximum charge, in which case the variable goes away and we're fixed again. So the top part above my mouse there is that fixed component at the top, fixed component at the beginning, variable in between. So clearly E is number 9, right? So we'll jot an E in there. Let's read F. F says cost of raw materials, where the cost starts at $9 per unit and then decreases by 5% per unit for each of the first 100 units, after which it remains constant at $6 per unit. Okay, so if we look at a cost where we're getting a decreasing amount per unit, we're going to get some kind of curve there until we achieve 100 units, in which case it remains constant. So the best case I can see of that is item 2, although we really don't see the constant portion, but eventually that line becomes a constant amount per unit. So in total cost, we won't see a decreasing curve anymore. We will see it sort of appear as a straight line. I'm trying to draw it here with my mouse. But as best we can tell from the charts that we're given, F is the line 2, graph 2 is described by F. Okay, let's go on and look at G. In G we've got some table data. City water bill, which is computed as follows. So the first 5,000 there's a 750 flat fee. Next 8,000 gallons we have to pay, it looks like half a cent per gallon. Next 8,000 it goes up to a penny per gallon, and 8,000 after that is 1.05. And we see this same pattern. So if we're looking for a pattern where we've got this increasing amount as it goes up, take a look at slide 11. We've got the constant fee up to a certain amount, then it goes up, continues to go up by a stepped amount higher per unit, right? So we're going to see an increasing slope as it goes on, and 11 is described by G. Okay, so let me jot in 11. I probably needed to put in a little bit more. All right, so now we get to H. H says cost of raw material used. Okay, and hopefully you understand that raw material is the perfect example of a variable cost. The more we make, the more we use. Therefore, we've got the straight increase. 3 becomes our variable cost, so that's H. Okay, let's cover I. Rent on factory building donated by the county, where the agreement calls for rent of $230,000 less $1 for each direct labor hour worked in excess of $90,000, but a minimum rental payment of $45,000 must be paid. Okay, so we should be looking for a minimal rental payment, right? So where do we start off with a straight line? Right there. And then we see the decrease in cost, and that decrease in cost is because there is less $1 for each direct labor hour worked, right? This is because it's donated by the county. They want to see us put people to work in excess of 90,000 hours, but at least there must be a minimum payment of 45,000. So we see that minimum payment at 45,000, the straight line again that occurs once we've put so many people to work. So 7 becomes I. Okay, and I think that's about it, right? Is there any more? Nope, that's about it. So we've got D, A. Let me go through these backwards. A was number 10, B is number 4, C is 6, D is 1, E is 9, F was 2, and G was 11, H is 3, and I is 7. And that really takes care of our various cases from A to I and the graphs that are matched. Now, part 2 does ask one other question. It says, you can't read it here, so I'll read it from the source of the problem, which says, how would knowledge of cost behavior patterns such as those above be of help to a manager in analyzing the cost structure of his or her company? Okay, well the point here is that if you don't understand the cost behavior, you're going to have a hard time making predictions about what will happen as a result of greater or lesser activity than what you were planned, right? The whole benefit of cost behavior patterns, in my opinion, is its predictive value. Okay? So, if we don't understand the patterns, then we couldn't make any statements about how we think they would behave until the cost were indeed had incurred, and it's after the fact, in which case we can't plan for it or anticipate what those costs would be. If we don't understand the cost behavior patterns, some costs may be increasing as activity goes up, while other costs may be moving the opposite way, meaning they're decreasing on a per unit or total dollar basis. Okay, so unless we have a clear understanding, we wouldn't be able to know what the costs were until after the activity. And I think that's the strength of understanding cost behavior patterns. That takes care of this problem, everyone. Thank you.